Hi, my name is Brayan. I am a doctoral student at UFRJ, Federal University in Rio de Janeiro. And I will begin my presentation for the IAS Annual Meeting 2021. And my work is entitled Torque Ripple Reduction using Hierarchical-like Fuzzy Controller of a 5-phase silent pole permanent magnet synchronous motor. The authors are Brayan, Fonseca, me, João Pinto, Walter Suemitsu, Raimundo Garcia, and Márcio Quimpara. I divided my presentation into 5 parts: introduction, proposed approach, I will talk a little about the fuzzy controller, some results, and conclusions of the work. The objective of this paper is to implement a fuzzy controller of a 5-phase silent pole permanent magnet synchronous motor drive aiming to reduce the torque ripple. And the novelty of this controller is that it operates as a hierarchical-like controller, so the speed control has priority over the pulsating torque control. And this feature was achieved by fuzzy controller because of the expert-based fuzzy rules. The fuzzy controller has as input reference speed, speed arrow, and torque arrow. The torque arrow is the electromagnetic torque minus load torque, and as output the synchronous reference frame according to axis voltage. This is a proposed approach on a basic scheme of the system. As I told you before, we have the 3 inputs here. As we can see, the difference between the load torque and the electromagnetic torque. The load torque is informed by a load observer, and the reference speed and the speed arrow. All these inputs are processed in the core of the fuzzy controller to give the VK, and the PI controller during all the time maintains this current ID in 0, because the flux is responsible only for the magnets in the rotor, and so the program processes this information to give the space vector PWM to find the IGBTs in the inverter, and so the motor generates the tension for the motor. It's important to say that this motor is a retrofitted 3-phase motor. Another scheme, PI controller based scheme here, the same variables, the same inputs we use for the PI, but it's important to say here that this scheme did not work, but I will show that in the result. Like in the fuzzy control, we have an PI maintaining the ID in 0, and so the same occurs here. The basic idea is that this equation gives the electromagnetic torque that is contributed by the excitation and the reluctance. If IDS is equal to 0, the term responsible for the reluctance is 0, and so only the excitation term will maintain in this equation. But for this machine and for many machines, this IKS is not constant, and this is pulsating. And what the controller does is to maintain this current constant. So that's the idea here, to maintain constant. The IKS for the electromagnetic torque maintains constant too. And talking a little about the fuzzy controller is that the idea of a fuzzy logic controller is to assimilate the experience and the knowledge of a human in designing a controller whose input-output relationship are connected in a collection of fuzz sets and fuzz heroes. One of the advantages of the fuzz controller, including the one proposed in this paper, is that they developed without the need of machine model, because besides the problem of the construction characteristics, there is the silence in the pole. There is the silence in the poles. And this is an illustration of what the controller does to control or to maintain a desired torque constant. As you can see, we have this disturbed torque here, and what the controller does is to cut the possibility to increase or to decrease, okay, cutting the current or inserting current to maintain it constant. And the fuzzy control has velocity to eliminate this disturbed torque. The PI controller does not have this velocity to do the same. Here are some membership functions of the controller. And here is a photograph of the system. Here we can see the inverter. Here is a multimeter to maintain, to verify the tension that is at the DC link. Here is the computer. I can monitor all the informations of the motor in this computer. But what basically the computer does is to download the program here inside the DSP. This oscilloscope is just to monitor the currents on the machine, to verify that everything is okay. Here is the protection device, and here is the encoder that informs for the program the position of the rotor, and with this position we can compute the speed of the rotor. And here is the DC generator that works as a load. Okay. This is our first result: speed variation as function of time. We don't see so many difference here because the pulsating torque does not give so many difference in the speed. But we can see clear that the fuzzy controller reduces the pulsating torque, the oscillating torque, as we can see at the black results. Here we have some other details of the results. For example, we can see clear that the fuzz cuts this part of the torque, maintaining it as constant as possible. And the standard PI with the load observer, we can see clear that the result is worse than here. So we tried to use the input of the PI controller using load observer to give the chance for the PI control the machine, but it didn't work. The result was not good, so it was better without the load observer. But even so, we can see clear the reduction in the pulsating torque that the fuzzy controls does. Here is the ID current as function of time. Remember that in both cases, the PI controller just controls the ID. But in the case of the fuzzy controller, as IK current is better controlled, the same will occur with the ID current. So we can see clear that even controlled by the PI, the result when controlled by fuzz is better. This is the stator current in one phase as function of time. We can see some difference here, and this difference shows during an FFT, a fast Fourier transform, that one harmonic is eliminated. Okay, so this harmonic is eliminated when controlled by fuzz, and this gives a help to eliminate the pulsating torque in the machine. And this is an experimental result for load variation. We can see that when the load is changed, the fuzz controls immediately control the machine, maintaining, reducing the torque oscillation. And talking about some conclusions, we could have seen that the experimental results show that the torque ripple using the PI controller is around 6 Newton in meter, peak to peak, while using a fuzzy controller is around 2.0 newtons in meter. So 3 times reduction. A fuzzy controller novelty was created to operate as a hierarchical-like controller, so the pulsating torque is working only when the speed reference is reached. And that's the idea of this fuzzy controller. The fuzzy controller eliminated the second harmonic of the current, which contributes for the torque pulsating reduction, as well as for losses drop. And this control has application for electric vehicle and the system that requires torque smoothing. And thank you very much for your attention.